Hello, welcome back to Cracking the Cryptic, and it's time for, well, a ton of gas today. So, normally when I take on the genuinely approachable Sudoku puzzles, I start off with, well, I'm going to be doing 5 puzzles today. What I actually do is often the same, but I do 5 days worth from the daily Sudoku channel where Clover, Philip Newman, and Sam Keppelman-Lyons put up a puzzle each, normally in rotation every day. But sometimes they have special days, and that can end up with me doing more than 5 puzzles, and that is the case today. So I'll get on to the rules of the puzzles and what we're going to tackle in a moment. I do want to thank the people who've been sending in really nice comments and solutions to the December award on Patreon. If you are with us on Patreon, you will have seen that the December award is a Cracking the Cryptic Mexican standoff, and 3 constructors unwittingly took part in a 3-way duel, and you have to work out the solutions to their puzzles, a quick meta puzzle to determine who is the winner and what one mystery number is, and send that to us to be in with the chance of a prize from the channel. And we're going to close that competition on the 20th. And thank you, as I say, to the hundreds of people who've sent in solutions already. Very well done. And I agree with everybody who says that the 3 original puzzles are excellent. I think they're really top quality. Now, that is on Patreon. On Discord, of course, there's loads of chat about Sudoku and the daily Sudoku channel. And, of course, there is now genuinely approachable pencil puzzles, Gap, and Simon has done another bunch and put it up as a bonus video on the channel today. So it's a really good day for the genuinely approachable puzzles, but that's going on. There's tons more on Discord. I do recommend it. As of course, our merchandise, that's all available under the video, and the apps, all our stable of 7 apps, and there is also Sven's Sudoku Pad, which is proving very popular, just $2.99 or the equivalent. Do give it a try. You can play all sorts of puzzles in our software in that. Now, let's have a look at the rules of these 5 days worth of puzzles. And they start fairly normally. We've got a puzzle by Philip Newman, which is a killer Sudoku, basically. Digits in cages cannot repeat and must sum to the total given, which looks like it's 8 in every case. So even in that cage, you can't repeat a digit. So those 2 can't be the same. Then we will go on to a Clover Windoku. Now, each cage basically contains the digits 1 to 9, as well as the normal Sudoku rules here. So it's a kind of 4th dimension, along with rows, columns, and boxes of the digits 1 to 9. Then we have Fortress Sudoku, and much as I like doing Windokus and think I'm good at them, I think I'm poor at Fortress Sudoku, so we'll see how that goes. Now, the extra rule here is, Sam's expressed it very clearly, wherever a shaded cell and an unshaded cell are adjacent, the shaded cell must contain a larger value than the unshaded cell. So if this was an 8, for instance, which it can't be because of this 8, but never mind, that would be a 9, and that would have to be the case because of the shaded cell rule. Let's do that over here. If this was an 8, which is possible, actually it's not, that would be a 9. Anyway, let's not worry about the mechanics of that till we get to it. Now, then we get on to day 4, and this is where things start getting a bit squirrely. This is this one's normal enough. Foreshadowing by Philip Newman. Normal Sudoku rules apply. Digits in cells separated by a black dot must have the ratio given. So that's a 1 to 4 ratio. Digits in cells separated by a white dot must have the difference given. So the difference and the ratio in each case in this puzzle is 4. But then look at the next puzzle. It actually came out on the same day, and it's the same deal, but with 3s. And then the next puzzle is exactly the same rules, but with 2s. And I think all 3 puzzles came out on the same day. And I don't know if the gas guys have done 3 9x9 puzzles on the same day before. It seems a bit of a strain to me. And we're not finished with the crazy fun, because on the 5th day, Clover put up this puzzle. Now, don't worry if you can't see some of that because of the screens. Basically, this is called the world's smallest puzzle hunt, and you can click on the rules in the Penpa thing, but don't worry about that. As I say, what I've done is I've put it into our software as 3 separate puzzles, but they are connected. So the rules are these. In all 3 grids, 1 to 6 must appear in each row, column and marked region. In grid 2, that's this one, digits must increase along thermometers from the bulb end, so that's smaller than that, which is smaller than that. In grid 3, this is killer rules again with 8. Digits in cages cannot repeat and must sum to the total given. Now, blue cells contain the same digits in the same order in grids 1 and 2. So you can see the blue cells are in the same places. They're going to be the same digits carried across. And that's what makes it a hunt. And in orange cells have the same relationship between grid 2 and grid 3. So they're all connected. It's possible that this form is the easiest to solve it in because you can see all 3 grids at one time. And I did think about trying to build it in our software in a kind of 6x20 grid, so you could see all 3 at once. But I think on some people's devices that wouldn't all appear. So I think the safest thing to do is to treat it as 3 puzzles, and that's how I'm going to be trying to solve it. If you want to do the Penpa version, I have left the link in, so you can try it there if you want. I don't really like solving in Penpa as much as in our software, because I can't really control the pencil marks so much. Anyway, that's what we're going to be attempting. Lots of explanation, although actually each individual puzzle is relatively simple to understand, which is often the case with gas. But it is a ton of gas. I am looking forward to getting on with it, and I'm going to try and remember to restart my clock with every puzzle so I know my times. Let's get cracking. So lots of given 8s. In fact, there's only 1 missing. That goes there. Now, right. In 2 8s in a cage must be the numbers 1, 2, 3, 4, and 6 to make 16. It's the only way you can make 16 in 5 digits. So we get another of those up in box 3, and 1, 3, 4 has to be the 3-cell cage, 2, 6 has to be the 2-cell cage. So that applies in the columns as well. So that's 5 or 7 with a 1 or 3 there. Now this has to be a 5. It sees a 1, 3, 4 triple, a 2, 6 pair, and 8. Biggest digit you can put in a 3-cell 8 cage is 5. So that fixes that as a 7. This is a 9. 5, 1, 2. So they're not 5. We get to place 5. That's not 1. We've got 3, 4, and 6 to put in the bottom row. Don't quite know how they work. That can't be 1, 3, 4 because it would clash with that, for instance. So that's a 1, 2, 5. 2 and 1 are already in this. I suspect I've done exactly the same thing I did down there in a totally different way. That is just what goes on in my brain, sorry. 5, that's not a 1. We've got 3, 4, and 6. Yes, it is very symmetrical. Now, we need to do something else. What's this? It can't be 1, 2, 6, 7, or 5. It can't be 4 because that would need another 4. So I think it must be 3. 5 is there, and then a 4, 9 pair. It's interesting how 4 and 9 are the digits we have the least information about in this puzzle, realistically. Now that 1 says there's a 1 in one of those 2 cells, which says there's a 1 in one of those 2. Suddenly we get the 1 in this cage on the right. That must now be a 2, 6 pair because it can't use 1 or 5. 2 can't be there. It could still be 1, 5, 2. I don't know. Right, 8, 1, 7, 2, 6. 5 is there by Sudoku. Okay. That 2, 1 pair has been resolved. That resolves the 6, 2 pair. That is 4 or 9, which I can see gives me a pair in the row. And there's a 2, 6 pair in that row. So I've got to use 1, 3 and 7. Right. Well, that's got to be 1, 3 there and 7 there. That gives us 9 and 4. That makes that a 9. This is 2 or 6. Well, it has to be 2. 5 and 1 can go in. Yeah, I think I've got onto this one. 4 to finish the box. 3, 6, 9 here. That is going to have to be a 3 because this can't be a 2. So 6, 9 pair. That fixes this stuff mostly. That can't use 5 or 6. It's a 1, 7 pair. 6, 1, 7, 8. That can't be 3. Come on, that's where 4 goes in the box. 6, 7 pair. 9, 7, still don't know enough there. 7 and 9 can go in. This can't be 6. 8. That is a naked single. Still got a few 3, 4 pairs knocking around at the top. 1, 5, 7, 6. That is a naked single 3. Right. That's helpful. 3 there. That's 1, 4 there. This must be done. 7 and 6. Yes, okay. 7, 1, 9, 6. That's now 3. Yeah, everything has come together, and unlike most Philip Newman puzzles, that one has been fairly straightforward for me. Very nicely put together, though, the way the 8 relationships worked here. It certainly helps to have done a fair amount of Killer before and know the 8 combinations. Excellent. 4 minutes 47. Hopefully that'll get me 2 hats for a Philip puzzle, and we move on to the first Clover puzzle for the week, Windoku. So let's restart my clock and look at this. Right, we need a 5 in this cage. No, not interesting. Oh, come on, where do we start here? 4 in this cage is in one of those 2 cells. It's almost too much to look at in this puzzle. It doesn't tell me where to begin linearly. 1 in this row. Right, given the cage dynamics, we can see where that goes. That is 6 or 9. Yes, let's not forget, these are other implicit regions. So within row 2, 3 and 4, once you take out 2 sets of the digits 1 to 9 in the cages, these marked sets must be another group of 1 to 9. So this 4, 5, 6 is very helpful in determining how they fall out. So that is actually quite useful. Let's do the same here. 4, 5, 6. That can't be 1, 2, 3. So 1, 2, 3 go in like that. Yes, a little bit of Windoku knowledge. Very helpful here. Trust Clover to build that in. Superb, as always. 1, 2, and a 3 in the middle. 3, 8, 7, 4, 5, 6. So that's 9. We can finish off 1 and 2. Actually, these perimeters unusually are being the most helpful part of this puzzle. 9 there. We can do 7, 8, and 9. Look at that. I can probably... Can I finish this one? Yes. 8 must be there. That's a 7. 6 there. Just that 7, 8 pair left on the perimeter. And now I can probably finish most of the cages. Let's choose somewhere useful. This box, we can do 4, 2, 3, 7 and 6 in the row. I'm going to change to this column. 9, 4, 6. Then column 8, 9 and 5 in box 6, and 7 and 3 go in. 4, can't decide on, yes, I can decide on 2 and 5 thanks to the Windoku boxes. 1, 6, what have we got here? 5 and 8. Yes, we obviously know 2 to finish the box. That's not a 5, so that's where 5 is. 3, 1, 2, 5, 9. That's a naked single 6. So that makes that 4, and we can finish 8 and 7. And this really has, you know, just that little bit of knowledge about those implicit cages really made a vast difference on this puzzle. 4, 3, but that has turned out to be pretty straightforward in the end. There we go. So just 3 minutes 10 seconds for that. I think you'd probably be a lot slower if you didn't know about these implicit hidden regions. There are others. So obviously that's one set. That's another. By the same token, there's 3 columns full of the digits 1 to 9. You remove 2 groups of those digits there. So you can do exactly the same thing looking horizontally. That's one set. That's one set. And when you've taken all of those sets out, there's one more implicit set of the digits 1 to 9 in a Windoku in those cells, which, as you can see, are all different. So good knowledge there to have for approaching Windoku puzzles. Now, Fortress. I wish I knew tips for Fortress, and I don't. So I'm just going to crack on. Now, we do get quite a few givens. So 2 in the top row, I can see, is there, just Sudoku. That can't be a... Oh, it could be a 9 or a 4, bother. That can't be a 9 because it's next to a window cell. So actually the top row is suddenly done. Let's have a look down the bottom, see if Sam's been just as generous. What can this be? Can it be a 3? Or does it have to be a 7? I think it could be a 3. No, it can't be a 3 because that can't be lower. So it is a 7. This, however, could be a 3 or a 5. Oh, this is next to an 8. That's helpful. That's next to a 6, and it can't be 8. That's next to a 7. Oh, there are some giveaway fortress cells. Look, there's quite a lot surrounding these 6s and 7s. That one is an 8. Yes, 8, I said. This one is a 9. Good. Just need to spot them and I'm fine. That one is an 8. Okay, that's a 9. Yes, Sam has clearly put a lot of quite big digits next to fortress cells. Now, where's 2 going to go? It can't be there. Surely this is going to have to be 5. I suppose it could just be a 3. That is 4 or 5. Now that's quite low for a fortress cell. The digits either side of it are going to have to be less. So they're going to be 2 and 4, and that is a 5. So that's a 3. Okay, so this does just work, unsurprisingly. That's become a 4. There we go. So 6 and 9. Sam really did make this approachable, and just because I'm so used to struggling with fortress puzzles, I was not really getting the point of how he had done so. That's where 6 goes by Sudoku. Now this must be bigger. That's a 7. The whole enterprise can sometimes be unshipped if you forget. In one case, you might suddenly think that grey has to be lower than white, and that can really throw you off. I've had that problem many times in Fortress. 8, 7, 6, 9, 4, 1. No, that... Right, this has to be lower than 5. Yeah, that's all. Everything in the row has to be now. 4, 9, 6, 7, 2, 5, 7, 9. 8 goes there. There's one more 8 to put in the grid, right? Do a bit of ordinary Sudoku. Now, in this row, that can't be 9, that can't be 9, that must be 9. This can be 4 or 5. What have we got? 4, 5 or 6. So that can't be a 6, right. So actually that row's done now. This has to be lower than 6. Yes, it must be. Right, down here, this has to be higher than this cell. But that's also 1 or 3, so that leaves this to be 5. 3 there. 5 in the column goes there. I'm not being very quick at this, even with lots of the puzzle done. This is a 1-3 pair. There seems to be a lot of 1-3 pairs still to sort out. That's another 1-3 pair down here. 8. Oh no, hang on. I've got 2 8s in the same column. Ah, okay, that has not gone well. I'm already 4 minutes in and I've completely messed something up here. Yes, I put 8 next to 7 there. What did I do that for? I think I said I needed the last 8 in the grid and I put it in the wrong place. Right, we'll go back to there. I think that's all right. That needs to be a 9. That's fine. I hope I didn't do that just as I was talking about how it is tempting to see. Look, I'm doing it again. I'm talking about it and trying to put a higher cell in there than there. My goodness, I'm losing my mind. 4, 5, so that's a 6. Right, maybe I should stop talking and focus. 5 or 3, 3 or 1, and that's also 3 or 1. So this is the same logic. 5 there, 3 there, 5 here, 4, 5, 4. Right, we're left with a 1-3 pair. I think that's still right. So, I mean, this is the antithesis of a lucky mistake. It's a mistake that deservedly was not lucky. But you have to find it and fix it if you do that sort of thing. Thank goodness for using the software, because it makes unwinding mistakes relatively straightforward. 3 in this column has to be there. Then we get a 2, 1, 5, 4 pair here. That's a 1, 3, 1. Yeah, the 3s and 1s are all unwinding, thank goodness. This way round, i.e. doing it correctly, unsurprisingly, there is a solution. 5, 4, that's a 5. 2, 3, and 2, 5. No! I put this 1, 3 in the wrong way around. Wow, I mean, that's been a mess. 6 minutes 23 is not a bad time, but been stumbling around in the dark. Let me just check the fortress cells to make sure I have got the right solution. Yeah, I mean, Sam was giving quite a lot of help here, and I was just constantly receiving the message and totally ignoring it like a fool. But got there in the end. Ugh, sorry, that wasn't a pretty solve. Kept on making errors. Tried to put an error in as I was explaining how easy it was to make errors. Had put one in previously, doing the same thing. Then a typo. Ugh. Okay, well that takes me in very poor form into the big days here. So Philip's Foreshadowing, and we try this rule set. I'm not sure, did he use exactly the same cells in the grid? Yes, look, he does. Oh, that is extraordinary. He's used exactly the same cells and places for markings for the 4, 3, and 2. I mean, that's amazing. I don't know if that means that our solve of the first puzzle is going to inform our solve of the second or not. Let's see. Who knows? Right, here we go. Let's get cracking on this. So that's a sequence. So 5's in the middle, and that's something that's going to be much easier with the foreshadowing version of this, unfortunately. That's not necessarily a sequence because those two can be the same. That is, though, in this box, that's a 1-9 pair. This now must be 2-8 since there's a 4 in the column. That is another even digit. Must be 6, mustn't it? Yeah. Oh, this is weird. I'd never used this rule set before with 4s. There's kind of relations I'm not expecting all over the place. So that's where 1-4 goes. That's where 2-8 goes. So that must be an 8-4. I can do the same up here, surely. Yes, 4-1-8-2, and that's 5-9, and that's the same on this side. Does this say a 5 difference? That's not a 4 difference. How strange. You almost think with Philip that's a typo, but it obviously isn't. Lots of people have tested these puzzles, so that's not going to be the case. 4 in the central grid is there. That's 3 and 7. 3 and 7 must always connect with 3 and 7 in this. And that's the sort of thing that will be different in the 2 and 3 type puzzles. What have we got? 2, 6 and 8. That is 2 or 6. So this is 2 or 6 as well. And we know which one. Yeah, that does work. That is 8 because this can't be 8 on the end. 8. Oh, I've got 2 8s in the same column. I am absolutely messing this stuff up. Oh, well, maybe that went wrong here. 937154. Now, I thought this had to be 2 or 6. How can that be an 8? We can't have a 4 here. So I've messed it up before that. Difference of 4 has to be 4 and 8. The 4 in these cells, they must be 1, 2, 4 and 8. There's no other ratio things. That has to be an 8. How am I going to get an 8 into... 8 can't be there or there. Can't be there. Wow, I'm going to have to start again, I think. Or at least wind it back so I'm not restarting the clock. I'm totally confused now. Surely this run of 4 gives us a 5. Must do, and that one must. They must be 1 and 9, and they must. That must be a 5, and that must be a 1 and 9. I'm fine with that. The ratio of 4 thing, it's got to be 1 or 4, 2 or 8. It's got to be. This must be even, and it sees 4, 2 and 8. I can't have done anything wrong here. Where is an 8 going to be in this row? Can't be here because that can't be 4. Can't be here because they can't be 4. Oh, this is 8 to 2. Why did I think that an 8 couldn't be there? Hurts to be so oblivious to the rules. Why? Why am I being so ignorant of the rules of this puzzle? So I was fine, and I just had to get over, this is where 8 goes, and that's a 2. I just kept reading that as a white clue. That's what was happening there. No excuse. Now, this was going to be 3 or 7. How did I know that? Because that's all it can be in the box. Right, same up here. 3, 7, that's a 4. Okay, so I was fine. I was really fine. I just didn't know it. That's a 2, 6 pair. That's a 2 or a 6. That is a 6. Obviously everything. Oh, this is a 2, 8 pair. That's a 6. There we go. 2. That becomes a 6. 9 must be there. 2, 8, 4, 9, 5, 1. That's a 6. It sees a 3. it's on a 4 clue. Oh, I mean, there's no excuse for the botch I've made of this. That is 2 or 8, so this is even. Must be 6. Right. That looks like it'll get me through most of the rest. 1 here, 5 there. 3, 7, 8, 2, 1, 6. Still surprised that there is this 5 clue. 5, 6, 4. That is part of a 3, 7, 9 triple. Ah. So we get an 8 there. This is a 1. What is this 5 thing then? It can't now use 1 or 2, so it's a 3, 8 pair. Right, and that resolves all the 7, 3 nonsense. That is a 3. That's 3 as well. Oh yeah, these are done. 7 in the corner. 3 and 9. 3 and 7. I can finish off columns 1 and 2. 7, 2, 3. Can't do that 1, 5 pair yet. 6, 7, 5, 9, 7 there. A 1, 8 pair, there we go, and a 5, 1 pair. So that one took nearly 7 minutes, and I'm sure was easier if I didn't misunderstand what I was doing. Now, let's fire into this one as well. Again, we get the run, but oh no, this 3 can't use the number 3, so that's a 2, 6 pair. There must be a 3 in the other one, but that can be 1 or 9. Now it can't be 9, or that would be a run going down to a 3. Yeah, this is slightly different. That must be 2, 6 now. That's going to be 3, because there must be a 3 on one of these. That's the 2, 6 pair. That could be 9 or 5. That is 5 up at the top. That must be the 1, 4, 7 triple. This reminds me a bit of thruples from yesterday. That is a 4 if it connects to 1 or 7, and that's the other one of 1 or 7. Right. Sorry, I'm losing track of my cursor. Now, yes, this can't go 9, 6, 3, so it goes 1, 4, 7. Oh, that must be a 2, 6 pair as well. This can be now 5 or 9. Oh, there's a 5 thing again. Well, it can't be 3, 8 or 2, 7. So this time it's, oh, and it could be 4, 9 or 1, 6. Right, come on, 2, 6, 3, 1, 4. Where am I going next? Here. Doesn't use 2 or 6, so it's the 1, 4, 7 set. I think that's right, yeah. 1, 4, 7. This could be 6, 9, and that's all. Oh, lovely, right, that's a 6, 9 pair in the middle row, so 5 there. That makes it a 9, 6, 9 again here, 8 in the corner, 9 there. I hope this is all right this time. 5, 7, 9. Central digit was available from the absolute beginning, and yet again I didn't notice it. 4, 8, 7. That can't be 8. This is a 5. 2, 6, and 9. That is 2 or 9, making this 5 or 6. Well, it can't be 6. That's the last 9 in the row there. This is a 9 to finish this column. Oh, don't know enough about that. That can't be 9. That can't be 5. 2 and 8 to place here. And either way, that's going to make a 5 there. That is 2 or 8. Well, it can't be 8. So should try and use the black clues a bit more because they're pretty helpful. 4 and 8 there. Right, come on, keep going now. We're nearly there. 1 and 2. 4 must be there. Don't know where 8, 9 go. Ah, this 6, 2 has been, oh, that has been available forever. That is 5 or 8. So they're actually a pair of 5 or 8. 1 there. 7, 4, 6. Yes, these can all go in. 6, 2, 4, 1, 7, 3, 8 or 9. I still can't resolve those, but that does give me an 8, 9 pair in the first column. So I can fill in 2, 5, 9, 6, 1, 8, 4, 6, 1, 3, 5, 2. Something, some clue here. Yes, that's a 5. There we go. Very easy. Just need to spot it. 9, 8, 9, and now we've got 7 and 8. There we go. That is the second. So I shall move on to the third. Too Clever by Half by Philip Newman. Okay, let's start the clock. Here we go. So these are much less helpful, surely. They're all even differences. There must be an even number there, so that can't be 4, 6, 8. So they're all odd. And they must connect up to other odd numbers by the magic of parity. So there's clearly, oh no, I was going to say, does this work down here? Not as well. No. There's an even number on those. Yeah, the black dots, I mean, these are regular Kropke dots. Oh no, they're not. Well, the black dots are regular Kropke dots. They need at least one even number on them. But the white dots connect cells of the same parity all the time. Wow, this is definitely harder, or else I'm... Oh, well, look, I can put the 2 in the central cell immediately. Right, so those could be odd if they were 4, 6, 8, but then no, they couldn't because... Sorry, they could be even, except for the fact there must be an even there, so they're odd. I might have to go full colouring here because I don't know how to get into this otherwise. That doesn't use a 2, so it's 4, 8 or 3, 6. Oh, there is a 2 in one of these 2 cells by Sudoku, actually. That's a 2 as well by good old Sudoku. In fact, that is a 2 and that's a 2. Right, sorry about not noticing that. So that's a 4. This then is a 1. That must be an 8. That must be a 6. Wow, okay, that was where to start, and I couldn't see it at all. That's a 4, that's a 1, that's an 8 with 6 next to it. 3 and 5 going up. Yes, I can do 3 and 5 going down that side too. Now, this can't be 3, 6. It's got to be a 4, 8 pair. 4, 8, 2, so 6, 7 and 9 in the remaining cells in the column. Now let's do the parity colouring just because it might help. There's a blue. Okay, so 3, 1, 2, 4, 8. Now this can't be 2, 7. There's still other possibilities. 8, 4, 2, and 3. 6 is the only even number still to go. Oh, this can't be 3, 6, 1, 2, or 2, 4. So that's 4, 8. This must be even as well. That is the 6. Yes, okay, that's good. Now, from the colouring, these are all odd. So that's odd. Those are odd because they're connected by white. These are different from each other because of the 5. So one of them's even. So these two are odd. That sees all the odd digits. So these two are the even digits, 4 and 8. That must be even as well. That's odd. Right. That might give us a framework to get going. Do I know? They don't involve 9 or 7. So the middle one is 3 or 5. It's not really enough. These two are even, so that's even as well. So that's a 6-8 pair. That's 6 or 8, so this is where 4 is. 8, 6, 8, 6 there. That can't be 6, it is odd. So that's the even cell in the column, 6 there. The colouring is still being helpful. That must be where 8 is. Still don't know anything about that pair, or not enough. Everything here is odd. Oh, this must be a 4-8 pair now. Yes, I think that's only just become available. Good. So that's even. Everything else in row 8 and box 8 is odd. Those two in box 7 are odd. That's even. That's odd. Didn't think I was going to keep the colouring going all the way, I have to admit, but it has been remarkably helpful. Those two, for instance, have to be even, I can suddenly see. That's even. One little group left over there. Right, now I've got to use the white dots more. Oh, this one still. Oh, an even is here. Now, this is 1, 6, 3, 8, or 4, 9, isn't it? Yeah, it is. It's not actually that helpful. Curses. It's difficult to use these 2s when I don't know the disposition of very many odd digits at all. That can't be a 1, so 1 in this row is there. So that's not 1, 6. That is 5, 7, or 9. One of those must be a 7, so that's not a 7. Wow, this isn't easy. Philip, you're very cruel to suddenly throw this one in. That can't be a 1. No, that's not all that helpful. That could be a 1. One of these two is a 1. That's not useful at all. Oh, these are 2 pairs. So one of them's a 1, 3, and the other's 9, 7. I think that means this is 5 either way round. So that's got to be a 7, 9 pair. That now must be 3, and that's 1. I hope that logic was right. It felt right. But it also felt slightly the biggest stretch I've done in this puzzle. 5, 7, 9, triple. So we've got 1 and 3 up here, and they must be this way round. Well, that does work, so that's encouraging. 3, 5. This one is 7 or 9, so is this one. 5, 1. That is 7 or 9 as well. Oh, come on. Oh, that is... Yeah, no, it doesn't tell me what that is, just because it's 2 away from 6. Wow, even with another chunk done, this does not fall. 7 or 9 there. 5, 7 or 9 here. So 1 must be here. That's 5, 7 or 9 as well. So is this. So that's a triple again. 5, 7, 9, 3. That must be 1. And we can finally finish the colouring, which might be helpful for the evens at least. That's 4 or 8. Yes, actually those evens were done, so I could probably have done that before. 6, 4, 8. That makes that a 4. Oh, that 4 was on the old 5 clue. Right, so we get a 3 here. That's 7 or 9. We've got a 3-1 pair that's resolved there. That's a 7 now. 9, 7, 9 is here. Those can't have a 7. Oh, we can do those. 5, 9, 5, 7, 4, 8. This is 3 and 7. Oh, that doesn't tell me what it connects to. Just gives me a 5, 9 pair. That gives me a 7 here. 9, 6 I haven't filled in. That's become a 4 and that an 8. That does the last pair of evens. 7 connects to 9, connects to 7 again. There we go. Wow. That was slightly different. But I mean, you just have to admire the fact that Philip can create these puzzles with the same places for the clues. He almost is too clever by half. That is amazing. That was a really good puzzle. I mean, a little harder than gas, but then you've been introduced to the concept by the 4 and the 3. Brilliant. Anyway, now we're not finished. We go on to Clover's triple, her world's smallest puzzle hunt. Right. Okay, I'm only going to start the clock on this one. I'll try and finish on this puzzle so that we know the time, but I need to flick between the 3. Okay, let's go. So this is a naked single. It sees 1, 2, 3, 4 and 5. That's going to be 2 and 5. That's 4 or 5. Actually, that's 4 or 5. That's where 2 goes. So I'm tempted to take that straight into the next puzzle, but I can see that's a 4 in the region. Okay, so we're getting quite a bit of this one done. Oh, maybe you can finish, or very nearly finish, all of one puzzle at a time. That would be kind. It's not quite what I'm expecting, and it's not really normal for a puzzle hunt. That's a 2. Yes, I can finish that column. And I've got another blue cell and all the blue cells. So I must be able to finish this on its own because it clearly doesn't need any input from the other puzzle. I think. 1, 5. Yeah, okay. Now, I was going to be careful to try and not finish this puzzle because it would tell me the time. So I'll come back to this at the end. The blue cells I'm transferring are 4, 2, 3, 1. 4, 2, 3, 1. Well, that makes the thermo easy. Gives me some orange cells for the next puzzle. Sure, yeah. This can't be 1, 2 or 3. This can't be 2, 3 or 4, so it's got to be 1. But now we've got some options. That can be 2 or 4 or 5. That can be 3, 4 or 6. So 6 here. 3 and 1 to finish the row. 2, 5 pair that I can't resolve. That's a naked single though. 5, 6 pair and a 4, 1 pair up here. That is 4 or 5. It's a 2, 4, 5 triple. 5, 2, 4, 3. That's 1 or 6. I mean, it's information I could easily transfer over. I think I will. So the orange cells are 3, 1 or 6, 4 or 5, 2. 4 or 5, 2. Well, that's in an 8 cage, so it's not a 6. So let's go back knowing that that's a 1 and see if that helps. 4, 1. I mean, I think this is a perfectly legitimate way to solve this because I think that's normally the intention in a puzzle hunt is you transfer information between the puzzles. So I feel no guilt. And I haven't managed to finish it, so let's go back to the last one. Right, 3 must go with a 1-4 pair. 2 goes with a 5-1 pair. Even in a 6x6 puzzle, that's true. That is 4 or 5, so there needs to be a 1 in this cage, and now that can't be a 3, so it's become a 5, which we can take back in a moment into the other puzzle. But let's try and finish this one first. We need a 1 there. This now must be 1, 3, 4. Over here we need a 1. Don't know what cage that is. What about this one? Can't be 1, 2, 5. So that's 1, 3, 4. This is now 1, 2, 5. That's all the cages done. 6, 4, 2, 6, 3. Right, that's fairly straightforward. So I think this puzzle is going to finish reasonably quickly now. 3. I haven't got any of the puzzles finished at the moment because I left 1 digit in the first one. That finishes that one. We take back a 5 into the previous one here, and that should let us finish this. Oh, that 6 has been available. Maybe that could have finished. I didn't notice that. 2, 5, 2, 6. We get a 1, a 6. This is on the thermo to do the deadly pattern. There we go with puzzle 2. Back to puzzle 1, put in the last digit, and 4 minutes 21 for the triple. So it is the world's smallest puzzle hunt, and certainly not the world's hardest, but that's fun. Even at that level, it makes me understand and confirm that I do love doing hunts. When they feed into each other, it's really very satisfying to go through them. But nice puzzles, as always, by Clover. And thanks for a bit of light relief after the toughness of Philip's Too Clever by Half, which was the one puzzle there that really gave me pause. Now, it would have helped if I hadn't been making mistakes on the Fortress and on Foreshadowing, but I can live with those. Great fun, as always, with the gas, and hope to see you again soon on the channel. Bye for now.